Good afternoon, everyone. Welcome to our today's webinar organized by Stanversity. Today, I have an amazing guest, Professor Dennis Kolberg, who is an absolute expert in Internet of Things, automation, process automation, anything related to automated autonomous factories. So it will be absolutely amazing to have someone like him today with us. Ladies and gentlemen, please welcome Dr. Dennis Kolberg. Hello, Dennis. How are you doing?
Hello, everybody. Great to be here. I'm doing fine. I hope everybody else and you are also doing fine as well.
I'm good. Like I'm always good when I have amazing guests. So it's really like a fuel for my engine. So, Dennis, first of all, thanks for finding the time to be with us today, and it's already afternoon. So let's have this super awesome, valuable conversation today. Could you maybe, as for the icebreaker and for the introduction, could you tell a little bit more about yourself today to our audience? What's your story?
Of course, yeah. Well, as you already mentioned, I am since around about 8 to 9 years in IoT, and well, starting from my first touch point with IoT, it was back when I was studying, like most people, when they first time got in touch with Industry 4.0, IoT, and so on. And I still remember it was an assignment about IoT, and that was for me like, wow, what is it? But after a certain time, I noticed there's something huge coming back in 2013, 2014, something huge is coming. And that was actually, for me, really the starting point to go into the direction of Industry 4.0 and IoT. And well, by that time, I think if I look back, it was 2013, quite interesting. By that time, nobody in industries was talking about the topic Industry 4.0. So I went to Kaiserslautern, to the German Research Center of Artificial Intelligence and the Smart Factory. It's, for everybody who doesn't know about them, it's actually the birthplace of Industry 4.0, the place where the term was also invented, as well as the first really vendor-independent Industry 4.0 machine was built up. For me, it was really, looking back, really great time, because I had the chance to talk to the inventors of this topic, learn from the people who invented the topic, build up not only theories, but also in practice, build up machines. I did my PhD in Kaiserslautern in factory automation, focusing on lean management, how to bring lean management into Industry 4.0 age. That was my PhD topic, and I was the head of research, had a team of around about 25 employees. Quite interesting during that time. It was engineers, software engineers, mechanical engineers, software engineers, psychologists, and it showed already by that time to me how broad this topic Industry 4.0 is, and IoT, how many different disciplines are involved.
Sure.
Well, and after that time, of course, it was more the transition into practice. I joined a consultancy as a senior manager for Industry 4.0. I went to practice, consulted automotive companies, food industries, how they can do the transition from this vision of Industry 4.0 into real use cases. Well, and nowadays I joined DIGIMONDO as Chief Product Officer. I'm part of the management team at DIGIMONDO, and I'm responsible for our software development. We are a software company building an IoT platform, this core part of every digitization strategy you have nowadays when you want to set up your digitized company, your Industry 4.0 company.
Yeah, so I've read a lot about DIGIMONDO. What you're doing, guys, is like amazing. Like, considering the client base that you're also having, you work a lot with the utility providers in Germany, right?
Utility providers, also industries, and I totally can confirm it's amazing what we are doing, of course.
Yeah, so like, I didn't know, by the way, like, while we talk, there are 2 points that I want to tackle here, but I didn't know that the IoT use cases for, like, generally utilities are very under, discussed companies, because they do with they work on utilities afterwards. So but if you look at that from the sensor and Internet of Things perspective, the use cases are pretty much endless there, right? All these like predictive maintenance, repairs. Like, could you like maybe show a little bit of the case study for one of the clients that you have done in the utility sector? Because I know that for Stanversity we're going to have some students from there, and that would be interesting as well.
Yeah, definitely. And you totally got it right. It's not that many people know about utilities and IoT, but if you think back, the topic smart city was even before the smart factory occurred or something around that. And they are pretty advanced in using IoT. And there you have endless use cases, starting from smart waste bins, where you track how's the filling level of a waste bin, smart metering if you have huge facilities and want to automatically track what's the power consumption and automate the process of billing to your clients. Then you also can use it in water pipes. Think about your city. You have water pipes, gas pipes under the earth, and you want to figure out, is there maybe a line broken, a leakage or somewhere? And these are just a few examples of our customers and use cases we realized and are working on, and especially in cities where you have a broad distance and everything is distributed and you have a lot of technology, a lot of infrastructure to maintain. As you mentioned, you have endless use cases and a lot of potential.
Amazing. So, no, like I didn't know that before. I was talking to people from here in Wrocław, from our own utility company, when they said what they're doing is that they're actually, creating patents of certain sensors that they're creating to, even understand the pressure in the pipes. It's really amazing. So this is one thing, and second thing is, like you said, that you were studying in a place where Industry 4.0 was born, Kaiserslautern, right? So, like, this was like when Bosch introduced it. This was that moment, because I think that Bosch was one of the first companies that went fully into the Industry 4.0. Or you were talking with Mr. Schwab. What is the origin here?
Bosch was one of the first companies following this idea, and they've also been part of the smart factory, a member of the smart factory in Kaiserslautern. And if you think back, the term Industry 4.0, it was around 2011 when it was first time occurred, and one of the people involved was Professor Walster. He was the CEO of the German Research Center of Artificial Intelligence by that time. So he was one of the people sitting together and bringing up this term. And on the other hand, I was in the department for innovative factory systems of Professor Zülke, and he founded the smart factory several years ago, even before the 2011, I think it was 2007. And he was really the guy who had the idea and said once, well, there's a smart home. Why is there not a smart factory? And that was the point where he founded the smart factory itself. It is smart factory. This is not a single company or research institute. It's more a big membership, or around about 40 members from industries. And like you mentioned, Bosch, Siemens, SAP, also smaller companies involved. And the mission was always, on the one hand, to do research, and on the other hand, with all these members, all these industrial partners, to bring this idea into market-ready products and push the idea of Industry 4.0 forward.
So what you're saying is that Industry 4.0 was actually invented on university rather than on manufacturing facility?
Yeah, actually, the term itself was invented in research, and especially in Germany in politics. Well, if you think back, there was once a political strategy. It was called High-Tech Strategy Industry 4.0, and that was the idea of the German government to focus research activities into the direction of IT in industry. And the topic was industry, or the name of it was Industry 4.0. And first time and to broader audience, it was announced in 2011 on the Hannover Industrial Fair. There they presented the high-tech strategy and discussed the term itself. And that was actually the beginning of this long journey 10 years ago, roundabout.
Yeah, we have the anniversary this year. So
exactly.
So it could happen only in Germany, where the thing actually was invented on university, was like kind of started from the academic discussion and evolved into the business. The way the business is connected with and business and science is connected in Germany, this is something that is always absolutely fascinating for me. So I like being there when it was born. It's an absolutely amazing experience. Dennis, so you're an automation expert. Can I call you this way? You're an automation expert, right?
Yeah.
So let's start from something that something that was told by Bill Gates. I have it prepared. There are like two things that he said about automation. It's like the very first rule of any technology used in a business is that automation applied to an efficient operation will magnify the efficiency. And then he said that the second thing is that automation applied to an inefficient operation will magnify the inefficiency. And like, what do you think of it? Like, as a starting point for our discussion, how do you usually tackle this within like as a consultant when you work with the companies?
First of all, I totally agree to it because of different arguments. And as I mentioned, I was doing my PhD in lean management and digitization. And before I was really convinced of lean management and had a lot of discussion about does it make sense to use more technology in lean management? And the other way around, if you think about this statement, it means, well, if your process is inefficient and not lean yet, and you didn't put away all the waste and all the stuff which doesn't bring value in your production processes, and then you start to digitize it, you actually start to digitize an inefficient process. So why should it become more efficient if it was inefficient before? And besides, you put technology like a blanket over the problem. You're not solving the problem itself. You put more technology on it to cover it. You're focusing yourself on technology instead of really solving the core problem itself. So that's actually why I totally agree on it. And besides, yeah, you increase the inefficiency because technology always costs money. You always need a project. You always need a project team for it. You always need to invest into technology. So in the end, the inefficiency gets more expensive because, yeah, you have this inefficient project. And that was always when people ask me about doing a digitization strategy, introducing IoT in production and so on, I always stressed before, are they lean? Did they before think about a clear process, put away all the waste, all these typical lean techniques? Did they introduce this before they start to do digitization? From another point of view, it also makes sense to start with lean first. With lean, you are more working on the processes and methods itself, which is very cheap. You can do it with a little money. You can do it internally. And if you solved everything there and you come to the point, well, I can't find 5 to 10% of improvements anymore, then you can start about thinking, switching to Industry 4.0 and trying to do it in a different way. And
So if I solve all my problems through lean, only then I can move towards Industry 4.0, right?
I recommend it always. There are many companies not doing it this way, and you can do it that way, but it's not the most efficient way, of course. So I always recommend to first be clear about your processes. It's like Bill Gates, the statement of Bill Gates on the one hand, and on the other hand, there was one statement of Steve Jobs once. If you clearly understand the problem, the solution is pretty easy. And that's actually what what I just mentioned. When you understand the core problem of the inefficiency and solve it, maybe with the lean first, then the solution with digitization is even easier. Yeah. Otherwise, you put the blanket over it and you just cover to make the problem even more complex.
Yeah. So, but in other words, to say, in order to automate, you need to have the right process in place. I like Tomasz Kośmider, who was our previous guest, like one of our first guest speakers in our webinar sessions. It was in Polish, actually. He said that you can't go into Industry 4.0 if you're not fully lean, right? And this is probably something exactly aligned with what you just said.
Yeah. And from my past experience, I've seen a lot of companies starting a project in virtual reality or AI or introducing a lot of robots into their production environment. And they were always struggling with the topic, what problem do I actually solve? They didn't find a good use case, a good return on invest, because they didn't understand what problem do I want to solve. They directly jumped in and using the technology. instead of first thinking about what's the core problem I want to solve, what's the process I want to improve. So yeah, that's actually why I always highlight lean is quite important in this.
Okay, but why do you think this is happening? So why are we so rushy? Like we're rushing so much towards actually, you know, having a virtual reality or 3D printing machines on in our shop floor, rather than, you know, trying to fix these problems in an analog way.
Yeah, I think it's different reasons. On the one hand, of course, Industry 4.0 was very present in media and in marketing, of course. And if you hear it every day, you also want to try it out and figure out, is it something I have to care for? Is it something I need to care about? So people forget what different problems I can solve or should solve first. That's the one perspective. Applies to some companies and organizations. The other point is also, if you need to think about in which department are you talking about the topic. If you're more in an innovation or research department or pre-production department, where it's more about evaluating a technology, does it have potential for my company, in-house smart factory, so to say, then it totally makes sense to start with this topic now, because you need time to build up the experience, the skill set in your company. You need time to understand, how can I use it for my product, for my processes, and then it's the right time. But if you're more already in the operational processes, in running production environments, yeah, then in many companies, or not many, often it's too early or not too clear enough what problem you want to tackle.
Okay. So how can I get this problem clearer? If I how should I start?
Yeah. Usually, first of all, I think I'm repeating myself on this, but it's like this: you need to understand the problem you want to solve. You need a hypothesis, a use case, or whatever, a point where you say, I noticed that my costs are getting higher and higher, or the throughput time is too little, or especially nowadays when you have shorter life cycles, the flexibility when I need to rearrange my production lines is not good enough. And then I can start think about, how can I solve this problem? The first question is not only what technology should I use, but more, how in general would I use this problem? And first step in this direction, of course, is thinking about lean methods and lean ways. Can I solve it with lean? And if I did everything in the lean direction and figure out, well, I can't really solve the problem, it's only 1 to 2% of efficiency I can gain, then think also about, what can I do in the digitization way, or IoT and Industry 4.0 direction? How can I solve it? It's another tool in your toolbox you can use, you should consider, but it's not always the best solution, to be very honest with it. It's one more tool you can use with is really powerful, but it's not the right knife for every meal you want to eat.
Sure thing. Okay, so maybe let's switch gear a little bit. So if you could explain to someone who's maybe not fully familiar, how would you explain the IoT concept and an actual application of it?
Yeah. Well, when my mother asked me the first time, what is these IoT sensors and actuators, I took out my smartphone and I showed it to my mom and said, well, that's actually IoT in there. It's not software running on a server somewhere. It's about sensors who can gather, feel the environment, like the brightness sensor on your mobile phone, or the gyroscope for accelerations on your mobile phone. So getting this information from the real world, and on the other hand, putting it through software, through automated processes, through IT, and on the other way, changing the environment around me. For example, if my mobile phone plays a sound, it's playing the sound to the environment, or if it's vibrating. If you think about a production environment, it means where you before had single machines who are focused on one certain part, are not connected with each other, not connected with the IT world. They suddenly use the sensors they have, for example, to figure out with a light barrier if there's a new product coming into the machine, or sending out a message to an IT system that goods are ready for being picked up with my logistics. That's IoT in production. And the core concept around it is the technical concept and the background is connecting all the machines and IT systems in your production environment. And on the other hand, using sensors, actuators to interact with your real world environment.
I was actually thinking, like in the past, I was actually thinking it must be super hard to implement these sensors into the machines. But actually today I had a conversation with one of my clients who is from our different company, Value Ships, where we consult software businesses. And he said, big up for you, Grzegorz. They are producing software for actually visualizing the shop floor. So all with this in Industry 4.0 trend. And he said that they just need to plug to the electrical grid, where, for instance, there is this green lamp showing that the widget was produced, and it's enough to already understand. And if you apply the time variable, it's already enough to understand the OEE index, right? Which is like how long the what is the time of efficiency of the machine, right? Mm-hmm. And is it true that it is that easy?
Yes and no. I'm sorry that it's not that easy to say. Yes, from the factory automation point of view, it was with the beginning Industry 4.0. When I started my journey in 2013-14, it was in factory automation. Everybody was saying, well, what's new about Industry 4.0? Where's the new product itself? The sensors, actuators already existed. The wires and protocols already existed. So what's new about it? Industry 4.0 is more about a new way of thinking. The IoT itself is as well. So from that perspective, you can definitely say, yes, the hardware itself is already existing since ages. And there are experts in factory automation who do things like this year for year. What's not that easy about it is the connecting all the different entities, the machines and IT systems with each other. It's always easy to have one single use case, one product, what you can bring into the production and clamp it in there and put a display over there, and then this use case is covered, it's working, it's doing predictive maintenance, it's doing KPI calculations for dashboards and so on. The challenge is more, the more use cases you solve, the more technology you bring in there. And then it's not only one wire coming from the green lamp. For the next use case, you need another wire, and then there's a next wire coming, and yet another one. And then you suddenly create a new kind of complexity. And that's, for example, the point where IoT platforms come into play. They are more the hub in the middle, on the one hand, connecting the machines, the logistics, the hardware, and converting data and forwarding it to IT systems. So yes, the hardware is existing. The protocols also, okay. There are a few new ones, but no, the more use cases you solve, the more complex it gets, and you need different ways to keep an overview and keep everything running.
So right now, what I need to think of if I am a head of production or a facility manager, I have all the hardware I need. I have everything. Now is the time to actually go and create this legendary digital twin of my factory, right? To go and actually have this stashed in some virtual place where I can see it in a slightly different way, right? If I understand this correctly, because in most cases I have all the hardware needed.
Most companies I've seen, they already have the hardware. They have PLCs which are able to be integrated in an existing network infrastructure using Ethernet protocol, Ethernet standard, for example, interacting with IT systems like your ERP, MES system, and so on. That's in most cases, especially for newer machines, let's say last 20 years roundabout, that's already state of the art. If you're thinking about protocols like OPC UA, for example, that's a bit newer, but there are adapters which you can just plug in front of the PLC, and then they are compatible. But I also have to say I've seen a lot of companies who asked me to give them advice about virtual reality, for example, and I came into their production environment. I've seen, okay, they have machines, but they are not connected with each other. So they are far behind from this stage, what I just mentioned before, everything is connected. If you're at the state, everything is connected, it's much easier, not for free at all, much easier, but still there are companies who have old machines, they are running, why should they exchange them? And for them, it's more a challenge.
Sure. So we already, by the way, we also have a question from the audience. I will just displaying it now. We will answer it later about the AI influence on industry for all. Just displaying it so you don't run somewhere else. But the question is rather, okay, so why we still need to have this conversation? So why we still need to, discuss whether it's possible to automate a factory, how to do it, why it's not some market standard in the same way as, for instance, lean management is. Like, why we still need to have this conversation after, like you said, like 10 years of fourth industrial revolution. I don't know how long was were the previous revolutions, but I don't think they were even that long in some cases.
Yeah, but you mentioned a good point. The question for where's the Industry 4.0 standard, like USB on my computer, where's the standard where I buy my machine and just have a look, does it have this industrial USB and everything is running? And yeah, when I look back and see how Industry 4.0 evaluated over the time, it was every time at the Hannover Fair, and we had a huge booth where I was also always there. The question was in the beginning, like, what is Industry 4.0? And then suddenly moved on to where's the standard itself. And then companies, users, organizations, responsibles understood, okay, you can't really bring out a standard and say, that's the one connector. We worked on something like this, for example, but it's not that easy to standardize it. And out of several reasons, on the one hand, from the physical perspective, the power supply, air pressure supply, and so on is different on many machines. That's more a technical aspect. And on the other side, it's about the data exchange itself. Just because you're using in your OPC UA in your machine and your ERP system is supporting OPC UA, it doesn't mean that the messages they are exchanging are standardized. For example, if you have a machine which is reporting a measurement like 43, and that's the way how old machines are programmed. They are simply reporting a value and the receiving IT system knows what it means because it was the same guy who developed it. Nowadays, if it's reporting 43, the first question is, what does it mean? Is it a temperature? Is it a measurement? Where is it measured? Is it in the beginning, in the end of the process in the machine, and so on? So we don't have a standard in this part yet. And there are some work done on standardizing this part as well, but you can imagine the one company is building cars, the other one is building tools, the next one is building toys. We have such a diversified production processes that you can't simply say, here's the one standard which always says a machine must report these values and an IT system must offer that interface. And that's it, you just plug it in. That's simply not possible. The other way is more thinking about a process and being aware of these topics that you need to focus on, for example, the interface description and semantics. What does this variable, what does the value exactly mean, what the machine is reporting? It's more about, if you're a bigger company, thinking about internal standardization. The next machine you buy, you specify and you remember, okay, we have a standard, we put it there. So we need a special interface that the machine is exchangeable in my network as well.
So this is more about additional layers of information that we are receiving than what we have received in the past.
Yeah, exactly.
Okay.
I think it's if you think about where the journey is leading in factory automation, I think most of these concepts are coming from software development. Mm-hmm. The idea of these flexibility in production and everything is speaking the same language. It's similar in software engineering. And previously, if you think about object-oriented programming, if you're aware of software development, it's about capsulating thing and defining a clear interface. What do I receive and what can I put in? If I put something in, what exactly do I get back? So it's more about the interface specification, one trend coming from software development because they also face complexity and modularity and exchangeability, and that's transferring now into production.
Sure, I get it. So if we have this all, like we all have this, we don't have the market standard, so we're in kind of in this fog, like technological fog. Okay, there's the question. I think this. Let me just read the question. That means a machine should have to introduce itself with meta information to a system first.
I hope I get the question right, but yes, in a way, it needs to introduce itself. If you think, I make one step back to understand the use case behind it, the why. If you think about flexible production lines and you're producing tomorrow a different good or a slightly different product, and you need to introduce a new machine, and you have this clear interface, of course, this machine must have an interface where it says, okay, I'm a new machine. And for reporting, I follow the standard we agreed on in the past. I can report my OEE, my throughput time, the maximum output day. And on the other hand, I also offer an interface or a standard that somebody, an IT system, can tell me when to stop or when to restart and so on. And I remember from my past, and that was by that time still research, and nowadays it's also research. It's more for the future. But for example, we worked on an approach like this, where you can join a machine, and the machine simply announces, like a web service or a web service documentation, simply announces, "Hello, I'm a new machine. I can produce. I can do 3D printing. I can produce goods in the size of 10 centimeters times 10 centimeters, and I need 5 minutes for an average product." That's what we've worked on in Kaiserslautern, for example. But that's, be very realistic. That's something of the future. I think we need a lot of time to come there.
Yeah, like so in software, you already have this no code, low code, right, concept where you can pretty much integrate everything, like even through Zapier, that you can pretty much, plug this with this, and there's like this hub that integrates everything. While with machines and this is already there, right? This is happening, and if you want to run any successful marketing today, you would pretty much do it. But with industrial concept, with the machines, when there is actual hardware production facility, it will still be it is still a long road ahead, right?
It's a long road on the one hand from the technical and hardware point of view, but also from the operations point of view. Think about if you are developing your small software solution for home automation for your smart home, then you don't care if the smart sensor for your plants breaks down or is one day not working. But in production environment, you have different requirements. I think everybody working in a manufacturing company can agree, if there's one day the production line not working, it will be a huge trouble for this company. And besides this, you also have security and safety standards you need to follow. Usually, from my experience, one of the biggest troubles or biggest points in companies was not agreeing on the technical solution. It was more bringing together two different departments, the factory automation, who's responsible for running the machines, and simply doesn't want to change anything because they are in charge if it breaks down. And on the other hand, you have innovation departments, IT departments, who want to introduce new technologies and need access to the machines. So that's more from the security point of view. And from safety point of view as well, at least in Germany, you have high standards. When you set up a machine and start the machine, you need a lot of certificates, and you can't just simply go there and change anything. And that's also one of the reasons why 10 years after Industry 4.0 came up, we are still in a transformation process, because you're not closing your company today, opening up another building in the neighborhood and say, that's my smart factory. It's more the next time you exchange the machines, the old machines, then you design them by the new concept, but it will take time until you exchange the machines.
Mm-hmm. Gotcha. We actually have few questions, so I think we need to start asking them before the lot of them. I still have some questions stashed, but I would rather answer the ones from the audience. So going from this, actually contextually. So considering the automation, how do you think how will the AI influence the industry 4.0?
In general, AI is a huge and powerful tool, and it will have a huge impact on industry. It's hard to say where exactly. I think predictive maintenance is one of the greatest examples. In production planning, I see a high potential, but I also have to admit there was a lot of research in the past, if I think about agent-based systems, successful research, successfully evaluated, but it makes things more complex, harder to understand for the responsible. So there's a high potential for it. But I also have to admit, everybody who's coming to me and asking me for AI, I always have to ask first, well, do you have the data already available?
Exactly.
Because every AI system needs somewhere a data, and not only one database where everything is simply put in and nobody cares about it. It's also about the structure of the data itself. Because an AI can only do what it's told to be done. So if you put bad data in, you will get bad results out. And I think it will be a long journey, and many companies underestimate this integration of different machines, all the objects in the production into one big infrastructure with IT systems connected. Yeah, and what I mentioned, IoT platforms, that's why I joined DIGIMONDO, because I'm convinced this is one of the core part. You need to gather the data, you need to clean the data, you need a semantic description of the data itself before you simply can start AI. And the better you do this job, the more powerful AI will be.
Yeah, so it is kind of like rebound from what Professor Gunal said during our business simulation webinar. It's like clean your data first and then move towards like further use cases. What I always say to my clients is like start from small data before you go into big data. And like if you, it is exactly the same with this automation, right? Because AI is an automation itself. So like apply to the efficient process, and you need to have, you can't run the automation on your CRM or your factory or anything if you don't have the right data. So try getting it there. Okay, another question is from Jelena. Hello from Serbia. A question. Hello from Poland and hello from Germany. In which industry do you think automation will be more soon applied, and in which one later? We also know that automation is more applied globally. How will that affect on number of employed people in the world? Again, like super broad question. I would rather ask you like other focus on the automation and the trends that you see worldwide.
Yeah. So I mentioned in the beginning, it's always about investment into the into technology, and in comparison to lean, it's not an operational cost which is going beside the project is running. It's more you need to first invest, set up infrastructure, and so on. So that means the bigger the company itself is, the more machines you have in your company, the higher the potential is. Because once you set up your let's say IoT platform, introduced predictive maintenance, to the more machines you can apply. So companies with a high degree of automation definitely are better suitable for Industry 4.0, and the bigger the company, the better it is. That's also one of the reasons what I at least observed in the past, why automotive companies started first with it. They have a high maturity in lean, they have a high automation, they are big companies. For them, it makes more sense to start to apply this technology. Besides, also companies with a high complexity, for them, they have a huge market potential. If you have short product life cycles and high variety, you have a very high complexity in your production processes. And that means when you can automate things there, produce complex products in an automated way, you have a higher business impact on this.
Yeah, but you need to have the volume, right, to automate.
Exactly.
Yeah.
The volume, or at least high pricing products. I see, for example, in not only automotive and consumer cars, but as well for production machines or agriculture, for example. You often have, take one simple example, a tractor or a bagger. They are always customized to certain needs. So the customer says, well, on my farms, I have large distances, so I need a bigger fuel tank, or I am allowed to use automated driving vehicles on my farm, so I want this one. So you have very different configurations. You have a high variety of products itself, and expensive goods. So that also makes sense to think about Industry 4.0.
Okay, so this is actually a good statement. So one thing is, if I have a huge volume, or if I have a good like more expensive products.
Yeah.
Okay. Cool.
I can also do the other way around, where it doesn't make sense, or where there's little efficiency improvement.
Go for it.
In Industry 4.0. And my best example is if you are manufacturing screws. A screw is standardized by an ISO norm. So, and I bet the next 50 years, a normal screw won't change. The standard itself won't change. The product is not that complex. It's a metal part which is drilled a bit and worked a bit on. So it doesn't make sense to think about flexible production and improve the already high automated process much more. You don't gain anything with predictive maintenance, or not that much with predictive maintenance or AI in these processes. You don't have the complexity in there. You don't have changing goods. You don't need the flexibility. You produced screws 50 years ago, and you will produce screws the next 50 years.
That doesn't really drive that much of a value. But I think that considering this additional questions that our audience have is like, so what are the challenges to implement IoT if a factory is a 50-50 on Rockwell and Siemens architecture? I would explain Rockwell and Siemens architectures maybe as a starting point, and then we can move forward. What do you think?
Yeah. So Rockwell and Siemens, for everybody from factory automation, they are well-known companies. They are producing hardware, especially hardware nowadays, software as well for factory automation. And Rockwell and Siemens are very famous for their PLCs. So for everybody who's not familiar with the term PLC, it's like the computer in a machine, so to say, in easy words. And Siemens especially, it's a German company in Germany. They are something like the state of the art or the standard if you're building up a production environment. I don't have figures in mind, but I would bet something like 70, 80%. I'm not sure, but I'm guessing right now, but something around this is used by Siemens. In other countries, and I think it was France and especially USA, Rockwell is more spread in these areas. And yeah, to pick up the challenge, if you have different types of PLCs, the point is they are using different standards for communicating with each other. Usually they have their own software for controlling and supervising the PLCs. So you need two different types of software or two different products to monitor these different worlds, so to say. If you want to bring everything into one common network, on one data highway, so to say, if you want to bring everything on one data highway, you need to find these common standard for both. That can be done on the one hand if they are programmable interfaces, that you define your semantic, your standard, and implement it in both PLCs of each manufacturer. Or that's another way. You have to watch out for adapters, edge devices, which are connected between the data highway and the PLC in the middle, something like a converter, which converts the data from the one world into this common standard I'm using everywhere in my company. But if you only have two suppliers, it's easier, much easier than if you have, for example, 3, 4, 5, or even one supplier which is not on the market anymore because the machine is 40 years old.
It's always the worst, like when you have the technology that is not longer supported.
Exactly. And then biggest challenge from my past projects I did is then in this case, if it's a machine which is very expensive, 40 years old, and still running. Because from a business perspective, you don't have a need to replace it. And the only reason you want to replace it is you want to introduce Industry 4.0 and you want to interconnect everything.
Got it. So this is actually I'm like, as you said about this all comes from the software world. It's exactly the same in software world. If you have different architectures, if you have different systems, you can't really connect it that easily. That's why these things like the integrators are so important, but we don't have them yet in the Industry 4.0, so we're kind of doing it on our own. Okay, so yeah.
The world is changing, luckily. I remember 5 years ago, it was really hard to find an integrator, a service provider who takes the responsibility to integrate everything. I mean, from their perspective, you always have to keep in mind they are responsible for implementing everything, and they suddenly should do something cutting edge technology. I would also say, well, maybe to be careful with this project. But it's changing. I've seen a lot of companies and I've been in contact with companies who also start to adapt to these new patterns, did their own research, did their own prototypes, experiments, and they are now getting into this topic and can even offer services that they can set up these environments, production environments, and integrate different technologies, and even say, yes, this is possible, and that maybe not.
Awesome. So Dennis, I probably like you like we're discussing very like actionable things, but our audience demands more from you, and they want to know a little bit of the global and worldwide level context. So let me just ask you these questions: is like, what about the automation in less developed countries like Pakistan, India, or countries in South America? What will happen to the workers there? Since the more developed countries outsource offshore factories there, will these countries suffer more because of automation than, for example, the UK?
Oh, pretty tough question, I have to admit.
Of course, this is no easy questions right now. You know, this is like this is the moment where there are no easy questions.
I'm an expert in factory automation, but not that much in economics, so it's hard to judge.
Yeah.
Well, in general, and that's even proven by a lot of statistics and research over the last, I don't know, it's not only the fourth industrial revolution, but also the previous revolutions. It was always that new technology didn't lower the amount of jobs. It increased the amount of jobs. It just switched from different domains. And best example is, think about the car. Before, everybody was horse riding, and then suddenly the car came up. And of course, everybody by that time, and it was even in newspapers, people said, well, what happened to the jobs right now of automated cars, or if cars are driving around and nobody needs a horse anymore? And if you have a look now, and at least in Germany, automotive industry is the biggest employing industry in Germany right now. So it switched. We don't need many people caring for horses anymore, but we have a lot of people in automotive. And that's the same also for the new technologies coming now. We've seen a lot of demand for people with technical skills, engineering or software development skills on the one hand. And I think this will increase worldwide. The demand will increase worldwide. And as I said before and in the beginning, Industry 4.0 is not like applicable for everybody. First is lean, for example. It's not applicable for everybody. So there are still a lot of domains where it doesn't make sense or where it's not applicable right now, nowadays. So how is the impact in these countries, especially? I have to admit, I'm not from economics or from any political side. I can't judge about it. If you ask me how I can integrate it, or what PLC you have in this company over there, I can tell you. But
yeah.
And this is pretty tough.
No, but like this is why. But I wanted to ask this question because this was demanded by the audience. Anyway, I think this is, as you said, like, there has never been a case study where it actually decreased the jobs volume and the productivity volume. It actually increases it, and even in developing countries, this is exactly the same. Okay, so another question is like, assuming that I want to get a job and qualification in Industry 4.0, what it is clear what and how to look for job and qualification profiles for Industry 4.0. I am assuming that this is like, what are the current job and qualifications that you would need to land a job as an Industry 4.0 expert?
Yeah, and there's really a change in the job profiles if you want to become an Industry 4.0 expert. And for example, in my case, I studied once industrial management, so engineering and management did my PhD in factory automation, and I'm now working as a product manager in a software company. So it shows what different skills you need. And depending on if you're more looking into a project management role, then that's a bit different than a technically oriented role. In general, you need at least 3 disciplines. It's the factory automation or electrical engineering skills. It's software engineering skills. And the third is more business perspective, project management, or especially use case evaluation skills. So more thinking about the numbers in this case. And depending on what part you want to play as an expert, it's more or minor more or less of each of these skills. If you want to become a good project manager for Industry 4.0 projects, then you should have good project management skills. That should be, of course, the highlight, especially for agile project management, because Industry 4.0 is more an iterative project than a typical waterfall project. But you need as well these technical skills from engineering, electrical engineering, and factory automation to understand what an engineer is telling you. If he's having a problem, to understand what is the problem, to understand the impact. And you also need to be able to talk to a software developer, understand if he's telling you this is an issue, this has impact, this is a technical debt, you need to understand and be able to give priority to this topic. And a basic understanding of this is needed. So if you're still in your studies right now and thinking about what can I do, and you're studying, for example, software engineering, I can advise you have a look into factory automation lectures, or the other way around. If you're more in mechanical engineering, do exercises or courses in software development. And if you're coming from the business side, then you should visit some lectures on both of it. And that's from my experience, and that was also one of the motivations why I'm doing lectures and trying to give all my knowledge to students. Right now, we have still at universities this thinking in fixed disciplines. An engineer is an engineer, a mechanical engineer is a mechanical engineer, software engineer is a software engineer, and a business manager is a business manager. And this is now changing. You need to do everything a bit. Not be an expert in everything, but you can't simply say, I'm just doing this because that was what I was educated in. You need to open your eyes and watch also to the other sides. And that's, for me, the motivation. I always try to give all my knowledge in Industry 4.0 to students, because it was my way how I became an expert in this topic. And I still believe that's very important, that everybody else who wants to be an expert in Industry 4.0 does a similar way.
So isn't it funny that actually in a very specialized and niche looking world, if you really want to become an expert in certain field, you need to be a generalist to some extent, right? It's like you can't be like, for instance, an expert, as you said, like you need to have these 3 things, and you need to have this wide perspective that you can share. And this is actually interesting that, it stays exactly the opposite of what was in the past. Like, hey, you need to find your one good job, be an expert in this field, right? It's not anymore. Even your story proves it, right? You're a man of jack of trades. That's how we would call it, right?
Yeah. But you're totally right. Yeah, it means if you want to become a specialized generalist, so to say, it means you need to study for 15 or 20 years. That's not possible. So the one thing is, be a generalist, but in one topic you need to be good. You need to specialize. That's the one way how you can do it. If you're more looking, for example, in the direction of being a good project manager or a digitization manager, like a chief digitization officer, in this direction, that's the path you need to work there. The other ways, if you want to become a good engineer, then you need to specialize on one topic, for example, software engineering, and have a look left and right and understand how a sensor and actuator works, how low-level programming works, for example, or the communication works. So you need to understand it. From a higher perspective, if I'm leading a company and need to decide who do I put into my team, then you need to consider or be aware that you need people from all disciplines, so that you're not only having a team full of factory automation guys, but you need team members from all departments involved in there. And you need to make sure that these people are talking to each other and understand each other, and also have respect for each other. That's also one thing I remember this workshop was quite in the beginning, one of the projects I did. We were sitting in a workshop room on our customer side and discussing about the Industry 4.0 machine, and discussing especially what is part of the cyber physical system, what's in, what's not. And there was a mechanical engineer who said, well, the cyber physical system is everything what's attached to this machine. That's the system. A software engineer said, well, a system for me is actually a software service running somewhere, and I don't care if it's running here or there or everywhere. And there was one systems engineer. He was asking, well, let's first define the system border, and everything can be in there and everything can be out there. And that was a long discussion, and people even got angry, and we need to take a break in between, that everybody calms down, because we were so much stuck in the discussion of what's in a system and what's not. And that's this example for understanding each other, not saying, well, the IT guys, they are always stupid. They are telling me different things I don't understand. It's more like, why do they think like this? Why do they come to this experience? And the other way, the project manager itself also has to say, well, there's an engineer telling me all the time that's technically not possible. The latency is too low, or the communication doesn't work. The data is incorrect. It shouldn't be the way of thinking, well, he's a stupid guy. I just need to put some pressure on him. It's more about bringing people together and say, well, can you explain it to me that I can understand? And then we find a solution. That's really important. Work together, find an understanding. And then you can have a project team with specialists where everybody's, where the overall, it's a general team.
Yeah, this is actually interesting that whatever you do, whatever automation you would imply, AI, big data things, cloud computing, virtual reality, blockchain, and everything, it all comes to the human factor and people in the basically this is super interesting. It all comes to people, but the way you said this software engineer, electrical engineer, and system engineer, it starts like like you would start telling a joke, like they all come to the bar, and then I was waiting for that. Exactly. I was actually waiting for a point, like the system electrical and software engineer comes to the bar, right? And then what happens next? This is like in this old that type of jokes. But this is exactly a good comparison.
Yeah, exactly.
So this is actually super funny. So we also have some comments from Frederick regarding AI. You'll most likely not get a certification, at least in manufacturing, because of the risks. A machine will run nuts if the AI is not trained well. And even if it's trained well, there could be a set of parameters which will give you the wrong result. So I guess it's a bad idea to control a device/machine via trained AI. Way to go.
Yeah, we have a broad discussion about AI in media, and everybody's saying, everybody's using AI, and you also must use it in your company, definitely, or you will use competitiveness and so on. And what Frederick just highlighted is one important thing. As soon as you apply AI, it's like you're training a baby. And when a baby made the first steps, it fell down and stood up and tried again and so on. Meaning for production, if you apply AI for example, controlling, doing production management, planning, and controlling processes, it means that the AI can do stupid things in the beginning because it needs to learn. And that's why you can't simply apply AI to everything, because as I mentioned before, you don't want to have 1 week of production outcome which you have to throw away because the AI thought it would be nice to put the engine in the back of the car. So it needs a lot of training, and it's also another topic as well. People are still in charge, and in comparison to the computer integrated manufacturing 30 years ago, we are now aware that humans need to control the process, need to be in charge, need to be able to understand what's going on. And with AI, it's tough, and we don't have the tools yet. We are working on it, especially in research. We don't have the tools yet to fully understand why did an AI decide this way and not the other way. What's missing, what training is missing to correct it or to improve it or to help it in this process. So it will be a very long journey until AI in production really is state of the art.
Exactly. So I think AI is still a little bit of like it's happening, it's the presence, but I think that it is still a little bit of the buzzword. It's a good amplification, but it will never replace. Like it will replace people in certain parts, but in mostly redundant tasks. But the robots won't kill us, and the Terminator is not there yet.
Not me.
Yeah, exactly.
And I bet we won't be alive anymore when it's time for this.
Yeah, iRobot thing is like, like just to wrap up a few thoughts. This discussion will be recorded. It'll be possible to watch on YouTube. We will post a link below after once we finish this conversation. And actually, Anna has this question: would it be smart for universities to start whole courses like Industry 4.0 expert and giving lectures about all the subjects? Dr. Kolberg just mentioned before: electrical, mechanical, software engineering, project management. Well, the funny thing is that Stanversity does exactly it. And this whole webinar is about to promote our courses, in which Dennis is one of our experts. And this is where we actually have this interdisciplinary course about a little bit lean management, a little bit of software engineering, about AI, cloud computing things. What is the system? What is not? Business simulation. So universities still don't get it, probably, most of them. But some of them do. For instance, Kaiserslautern University, this is a very good case of university that is great. But this is what we're doing. If you're interested, just visit more on stanversity.com. This is our website. And also we have a feedback that this is great. You're giving an answer to some important questions on how to prepare to a good environment for Industry 4.0. Yes. Like Dennis is Dennis is your guy, so feel free to reach out to him. He's you can find him on Google very easily. His contacts are everywhere. So. So in case you want to hire him as a consultant, feel free to do so. Dennis, do you have any parting words for our audience?
Well, first of all, thanks a lot for on the one hand to you for the webinar itself and for this lot of participants with really good questions in there. And yeah, from my point of view, you highlighted it perfectly. Stanversity has this program to give this broad knowledge. It's for you as personally, it's important when you want to start to be aware of the terms which are used and be aware how big is the potential of AI and so on. Be aware what are the first steps for proof of concept. Why is IoT and IoT platforms are so important? That's for you personally very important. And for as a leader or manager in a company, the important thing is to really get in touch with these topics. Be critical about it. Not everything what's told around is the most important. Really ask the question, why is it important? Why right now? And why should I use it? I think that brings a lot of understanding, and with the understanding, as Steve Jobs once said, to quote it again, if you understand your problem, it's pretty easy to find the solution on it.
Exactly. It is like one of the best parting words we could ever get. So Dennis, thanks a lot for finding the time, and looking forward to your classes, and it was an amazing conversation. Thank you for being here today with us.
Thank you as well, and have a nice afternoon or evening.
Yeah. Take care.
Bye-bye.